right, this is going to be section 4.3 that is going to be an introduction to logarithms. The intent is to split this particular section into 3 videos. This is the first of the 3 videos. Let's first of all take a look at what a logarithm is. For all real numbers and all positive numbers a and x, where a is not allowed to equal 1, then we would say the log base a of x is equal to y. And that is the same statement as a raised to the y power is equal to x. Now, the way I like to think about the difference between the two, if I want to switch a logarithm into an exponential, then what I will do here is I'll start with my base of a, and I'll raise it to the y power, and that's going to be equal to x. So I would use an e to change a logarithm into an exponential. If I wanted to change an exponential into a logarithm, I'm going to use an L. So we'll have log base a of x is equal to y. And you can see that there in the graphic that I have listed below, the exact same thing. The expression log base a of x is going to represent the power to which base a has to be raised in order to obtain x. A shorter way to say the same thing is that essentially a log is a power. A log is a power. Now, the number a, I keep calling it the base. So get used to hearing that phrase. And x is going to be the argument of the expression. I do want to point out that the base of a log and the base of an exponential are both, in this case, base a. So they are tied to each other. All right, let's look at example 1, where we simply want to switch back and forth between logarithms and exponentials. So we'll go through this pretty quickly here. This would, if I want to change my exponential 3 to the 4th equals 81 into a log, I'll use an L. So we're going to have log base 3 of 81 is equal to 4. And that's exactly what this is going to look like. Notice that I did put the dotted line in there. I want to point out that by handwriting, that base of 3 is the only thing written lower. It's like a subscript. Everything else, the log, the 81, the equals, and the 4, those are all written in a normal size font, if you would. I know you're not typing, but it's a normal font, a normal size. All right, so part B. We want to change the log into an exponential. So let's use the e. We'll start with the half base, raise it to the negative third, make it equal to 8. For the next one, we'll have a log base 10 of 1,000 is 3. For the next one, part D, we will have a 5 raised to the negative third is equal to 1 over 125. For part E, we want the logarithm, so we're going to have log base 12 of 12 equals 1. And then last but not least, 6 raised to the 0 is equal to 1. And we do know that anything raised to the 0 power is equal to 1, so that one's not a surprise. All right, talk about some logarithm equations and solving them. So you'll notice that we do here want to solve each of our equations. So here's some tips about this. First of all, write your logarithm as an exponential. If the power is unknown, you want to get bases alike like we did back in section 4.2, or you might log both sides, which is what we'll do in the future. If your unknown, your variable is not a power, then just solve it as normal. All right, so let's take a look here. For part A, the first thing that we want to do is we want to change our log into an exponential. So we'll have x raised to the negative second power is equal to 16 ninths. Get that out of the way there. And then what we're going to do is use our negative power rule that we looked at back in section 4.2. And so we'll rewrite the left-hand side. Now, the next thing that I'm going to do, there's one of two ways to look at this. And so one way is that you could cross multiply. You could take 1 times 9 and set it equal to 16 times x squared and then solve for x squared. That is one way to do it. What I'm going to do is I'm going to take both of my fractions and I'm going to take the reciprocal of both sides. This is also legal. So the reciprocal of the left side is x squared. The reciprocal of the right side is 9 over 16. And then I will take the square root of both sides. Let's not forget the plus or minus. And then the square root of 9 and the square root of 16 is going to become a 3/4. Now, the thing is here, I've got a little starred statement that says my x, my base, could either be a positive 3/4 or a negative 3/4. However, something that you need to know is that a base cannot be negative. So with that said, then, we're not going to keep the negative 3/4. We're only going to keep the positive 3/4. All right, let's look at part B. So once again, let's take our base of 16, raise it to the 3/4 power, make it equal to x. Don't forget your rule about fraction powers. You might need to go back to section 4.2 to relook that rule up. But fraction powers can be changed into roots. So the bottom number of the fraction becomes the root. The top number is the power. The fourth root of 16 is 2. If I cube that 2, I'm going to get an 8. All right, let's look at part C. So once again, let's go ahead and turn it into an exponential. So we have 36 raised to the x power is equal to the square root of 6. Let me get rid of my e there. So this is one where since the power is unknown, we'll try to get bases alike like we did back in section 4.2. So let's substitute 6 squared for 36. So we'll have 6 squared to the x power is equal to 6 to the 1/2 power. Clean up the left side, raise a power to a power, and you're going to multiply your power. So that's going to be 6 to the 2x is equal to 6 to the 1/2. And what I'm looking at here, there's a little bit more work than I intended to show. Sorry about that. But what I'm looking at is that, remember the rule that says when your bases are alike, your powers must be alike. So here is a miniature rule, a miniature equation of just saying power equals power. 2x, the power of 2x is equal to the power of 1/2. So now I'm just going to solve as normal. I will multiply on both sides by a 1/2. That'll get my x alone. And so then my x is going to equal 1/4. Now this says to describe a process for solving logarithmic equations, and this little tip list here would be the process for solving these equations.